A battery of EMF E and internal resistance R is used in a circuit with a variable external resistance R. Find the value of R for which the power consumed in R is maximum. Solution: the current in the resistance is I equals to E by R plus R. Now the power consumed in R is P equal to I square R or equals to E square by R divided by R plus R to the whole square. It is maximum when dP by dR equal to 0. This implies d by dr under bracket E square by R plus R to the whole square equal to 0, or E square into R plus R to the whole square dr by dr minus R into d by dr R plus R to the whole square divided by under brackets R plus R to the whole square equals to 0, and this will be equal to 0. Now we have to differentiate it. This all should become 0. So R plus R to the whole square. Now this dr by dr equal to 1, and R into 2 into R plus R, and differentiate it. This will be 0 and this will be 1. So 1. So R into 2 into R plus R into 1 equal to 0. This implies, now R plus R take common. This implies R plus R equals to R plus R minus 2R equal to 0. This implies R minus R equal to 0. R minus R equal to 0. This implies R equals to R. Thus the power is maximum when value of external resistance is equal to the value of internal resistance. Here we see that R minus R equal to 0. This implies R equal to R. Thus the power is maximum when value of external resistance is equal to value of internal resistance. This is known as maximum power theorem. Also maximum power, that is P max equal to E square into R by R plus R to the whole square, or equals to E square R by R plus R to the whole square, or equals to E square R by 4R square, because capital R is equal to small r. So now equals to R cancel, so E square by R, E square by 4R, E square by 4R, this will be E square. So maximum power is E square by 4R in the circuit. Here it is shown E square by 4R. Next, the coil of an electric bulb takes 40 watt to start glowing. If more than 40 watt is supplied, 60% of the extra power is converted into light and the remaining into heat. The bulb consumes 100 watt at 220 volt. Find the percentage drop in the light intensity at a point if the supply voltage changes from 220 volt to 200 volt. Here given rated value, we first calculate the resistance of the bulb. The rated value is given R equal to dr square by PR, 220 by 100 equal to 484 ohm. In the first case, when supply voltage is 220 volt, power developed in the bulb is 100 watt. Hence excess power equals to 100 minus 40 equal to 60 watt. So power converted into light equals to 60 into 60 by 100 equal to 36 watt. In the second case, supply voltage is 200 volt and P equal to 200 by 200 to 484 equal to 82.64 watt. Hence extra power 82.64 minus 40 equal to 42.64 watt. So power converted into light 42.64 into 60 by 100 or 25.58 watt. Now drop in power 36 minus 25.58, 10.42 watt. Hence drop in power, percentage drop in power 10.42 by 36 into 100 equals to 28.94%, equivalent to 29%. Next, the 2 ohm resistor. The 2 ohm resistor shown in figure is dipped into a calorimeter containing water. The heat capacity of the calorimeter together with water is 20,000 joule per Kelvin. A, if the circuit is active for 15 minutes, what would be the rise in the temperature of the water? B, suppose the 6 ohm resistor gets burned, what would be the rise in the temperature of the water in the next 15 minutes? Here the situation is shown. 2 ohm resistance is dipped into water. Now first we calculate the R equivalent. So R equivalent will be 1 plus, this is in parallel, so 6 into 2 by 6 plus 2, 1 plus 12 by 8 equal to 2 plus 3 by 5 by 2 ohm. Hence current in the circuit will be I equal to E by R equivalent equal to 6 by 5 by 2 equal to 12 by 5 ampere. Now I1 R1 equals to I2 R2. I2 R2 is I1 by I2 equal to R2 by, now I1 R1 equals to I2 R2 equal to I1 by I2 equal to R2 by R1, or this implies I1 plus I2 by I2 equals to R2 plus R1 by R1. This implies I by I2 equals to R2 plus R1 by R1, or this implies I2 equal to I R1 by R1 plus R2. Similarly, I1 equals to I R2 by R1 plus R2. Hence current through 2 ohm resistance, through ohm resistor, I2 equal to I R1 by R1 plus R2 equal to 12 by 5 into 6 by 6 plus 2. Solving we get 3 by 5 ampere. Hence heat released in 15 minutes, I2 square R2 into T, or 9 by 5 to whole square 2 into and T 50 into 50 minutes into 60 seconds. So we get solving this value 81 into 7 to 58 into 32 joule. This heat released will be gained by calorimeter and water. Now heat released equals to heat gained by calorimeter plus heat gained by water. So this implies 58 132 equals to C into del T. It is given C into del T. Hence delta T equal to 58 132 by C equal to 58 132 by 2000 Kelvin equal to 2.916 Kelvin. Answer. Next topic is loss of power in a transmission lines. Here a transmission line is, this is the generator, the source which gives current, and power of this generator is represented by PG, and voltage given by this generator is VG. And this is our wire, transmission wire, whose resistance is represented by R wire, and it is a home appliance, that is bulb, electric bulb or electric fan etc. Voltage about this bulb is VA and power consumed is PA. Let VG equal to PD, that is potential difference voltage of the generator, and PG equal to power of the generator, and I is the current in the transmission wire. Then VA, that is voltage across the electrical appliance, and PA, power consumed the electrical appliance, and R wire, resistance of the transmission wire. Now PG equal to VG into I, that is power in generator is equal to voltage in generator into current. Hence I equal to PG by VG. This is equation 2. Hence power lost Now power lost in wire, P loss equal to I square into R. This is R is the resistance of wire. So, and could be using this value of I, Pg square by Vg square into R. From this it is clear that P loss is directly proportional to 1 by Vg square, that is generator voltage. So to keep the losses minimum, power is always supplied at higher voltage or Vg. Generally Vg is about 33 kilowatt. Again now PA equal to VA into I, that is power in appliance equal to VA into I. The same current is flowing all over the transmission line. So power supplied by generator equals to power loss in wire plus power consumed in appliance so hence Pg equal to I square R, power loss in wire, I square R plus VA into I, this value. Equals to IR plus VA into I. Now from 1 and 5, Vg equals to Vg equals to IR plus VA. Vg equal to IR plus VA.